So what I'll be sharing with you guys in this video is going to be this door where it's fully parametric. We could change the location and all of the details that you see can be changed here. So we have the door swing, we have the location of where the door swings, we have the trim depth, size, and offsets. And what's cool about this is that as long as we have a line segment, let's say within a floor plan, we can override that parametric line segment and use this line segment. It doesn't have to be aligned in the X and Y. It can also be rotated in any direction. And so that's what I wanted to share in today's tutorial. Is going to be the work session where I create this. You'll also find another script and a cluster within the files that you download. If you want to download this, go to my website, capettidavid.com. There you can find this and other resources that can help you. But for the most part, I'm showing you how to create architectural elements using base geometries like, let's say, a line segment, and create a complete script or algorithm around that line segment, saving you time and letting you see all of the options before you decide on what you want to do. So hopefully you're excited about how this works and, making more progress in your parametric design journey. And let me know if you have any questions. Otherwise, stay tuned and let's jump into it. All right, so the first thing we'll do is bring in a parametric point so we can locate our line segment. So I'll go here to construct point, and this will give me a parametric point. I can also change the location of that point. Then I like to route it through a empty point component, and I'll plug that in. So that way I can change that location if I want to. Now from that point, we're going to be creating a line segment that's going to represent the center line of our door. And this, we can use different things. We can move that point or use SDL, which will give us the start of a line segment, the direction, and the length. So the start is going to go here. The direction is going to go in the unit X, and the length is going to be whatever size door you have. So let's go 3.0. All right, now with this line segment, let's extrude it up. So I'll bring in an extrude component and also the vector in the direction that I want to extrude. So it's going to be up in the Z direction. And then copy this over and plug this both into the direction and into the base. All right, so we've got the door, and this is going to represent the surface of where the door is located. Now, when you're creating a script, you have to know what input you want to use, because that's going to determine how useful your script is. Now, if you want to plug in a curve to create a door, then we would actually use a curve component here to be able to override this curve component and plug in any other curve. Now, if you want to override the surface, let's say if you already have a surface in a model, then we can see if we can put a surface here. And so the entire script would be based off of this surface. So depending on what input you want to have, you would take a different approach. Now for me, I actually want to start with this line segment because the line segment represents the location on the floor. And then we know that we extrude this up. What happens is sometimes you will apply a surface that is not oriented the right way, and therefore the frame and the other things we're going to do may not work the same. So now that we know we're going to be using this curve, then we will use this curve coming out of this relay, which I did by just double clicking on the input or on the output, and that gives you a relay, which we could also delete. Okay, so now we're going to take this curve and offset it both ways. So we'll go to offset curve, and now we'll go to 0.250, and we'll offset that curve to the one side by 2.5. I like to create a relay because we're going to be copying this down. So I slide it and tap Alt. It's different if you have a Mac, by the way. And then negative in this direction because we're now offsetting from the center line of where the door is out to each side. Now what happens here is if it's 0.5 here, well, this is 0.5, which makes it 1, which means that this number needs to be divided by 2, which we can do here. So you're starting to see that we can interject anywhere and add relays. And this will make it a lot easier for us to add components and stuff like this. Also, it helps keep it organized. All right, so we got 0.3, half of 0.3, half of 0.3, making it 0.3, the whole thing. All right, so now that's going to be the depth of the wall. This is going to be the door height. This is going to be the length. And you'll see later on that we can plug in any curve and create the door on that curve. So we're working around this line segment. All right, so now that we have these two curves, now there are a few things we need to do. We need to get the endpoints, and we also need to expand this out here to create the frame. So there's different techniques that we can use for this, but I'm going to show you a really interesting one. First, we'll bring in the endpoints because we need to create a frame. So we'll do endpoints for one offset, endpoints for the other offset. Then we're going to extend both of these curves by the size of the frame. So 0.250. And notice that we'll do the exact same thing to both. So I'm sliding down, tapping Alt to create a copy, creating two extensions that will also have endpoints. I'm sliding it, tapping Alt, and extracting the endpoints. I'm just trying to keep this organized so you can see all the wires and how they connect. Now, we're going to connect the dots. So now we'll go to Polyline. We're only doing one side. We don't have to do the other side. So we'll go start point to start point. So this one, these two don't go together. It's that one to this one. Then to this one. And to this one. Notice it creates that polyline. Well, now, if we look at this polyline, it's a closed polyline. So we can disable the preview on all of this for now. And now we can offset this. By whatever the frame size is going to be. So I'll copy this over. And now we need to turn these two into a solid. So to do that, I like to bring in the endpoints so I can close both the start and endpoints with a line, which will be represented by a line segment that starts at point A and ends at point B, but it has to be both the starting ones here and both of the ending ones here. So you're seeing that I'm going with the endpoints. And I'm joining all of this together using join curves. If we look here at the output, it says 2 values, so then we'll flatten it, making sure that it's only one polyline. Let's bring back that surface so we can see it clearly. All right, so what we need to do now is take this surface, we need to create a rail in which this frame goes around. So to do that, we need to deconstruct or explode this surface. When you explode it, you can pick one of these line segments. So when you have a 3D object, you usually have a surface, line segment, and points that create it. The points we're not going to use. We're going to use this line, and this line. So we'll start by list item. Actually, no, there's a better way to do this. And that is, let me show you. We're going to get the endpoints, and I'll explain why. Give me 1 second. Here's the reason why we want to do it this way. We want to create a line segment starting at the bottom, going up to the right and down. Sometimes when you extrude this, the line segments might change. So now we need to take this and move this up by the same amount of the door height. So we'll go to move. We'll use the same vector as the door height because we want to move both of these points up. So we have a polyline that we can create starting here and then moving up and around to create that frame. So we're starting with this point up and around. And now that line segment can be used to sweep this form all the way around. So now I'll go here to this one, and I'll turn it into a surface first. I'll go to boundary surfaces, and then I'll go to sweep one. This is going to be the rail, and this is going to be the section. So let's go here. And let's hide the input for some of these so we don't have all the wires going crazy. So let's look at this. The length changes, the height can change, and it's tied to the height here. The depth of the wall is going to determine the depth of the frame. Then if we move along, the extension is going to determine the trim size. And up here we have the depth of the trim, and the final result of the frame. All right, now let's create the door. So we've got the line segment here. If we were to offset this to each side, the same way that we did for the frame, but this time, when I bring this back, you'll see that it's been offset by that much. So we'll do 0.125. And since it's going to both sides, we know that this has to be divided by 2. Now we'll close it off using that same technique of bringing in the endpoints, connecting the start and endpoints, and joining it together. So the start and endpoints. Join together with these. So 1, 2, 3, and 3 and 4. I'll flatten the input. So now we've got this, and we've also got this frame here. Now we can take this, turn it into a surface. So we'll go to boundary surfaces. And we're going to take this and extrude this up. So we'll go to extrude up by the same amount as the door. Then we can take this and subtract it from the frame. So we'll go to solid difference between the door, which we want to keep, and subtract the frame, which will give us the result here. Now, the thing is that we need to have a spring point, which has to start down here, and this may not give us that result. So one thing that we need to do is then take these and get the extension. So extend this and this in the negative direction. So by the size of the trim, and let me show you what I mean. So the size of the trim is going to be the offset here. Now if we get the endpoints of this and this, we can pick which one of those points is going to be the one to rotate. So if we go to list item and we plug both of these in and flatten it, now it's going to only pick one, and now we can go between 0 less than 3. And now we can route through the first one, second one, third one, and fourth one. And that can be used for this. The result of this, which we can hide some of these wires, we can rotate relative to that point. So if we use this point as a plane input, this one as the geometry, we can bring in a slider. We'll say less than 45, less than 45, less than 90. Notice that that's the wrong point because it's picking that one over there. So then you do have to change this to be the correct number that it rotates. So at this point, we have most of the stuff that we need. The only thing that we don't have is going to be the door detail. So let's change that. If we go back to these that we extended, and we even go back to this being 0, now I want to extrude what I extended here. but I'm going to do both. Let's see, this one, the front and the back. Now we need to offset, so we'll do it to 1 because the other one is going to be the opposite direction. So first things first is we need a direction in which this is going to be extruded. So we'll evaluate surface, reparameterize. The point is going to be at 0.5 in the X and 0.5 in the Y, which is exactly in the middle. Now we're going to take this and offset it. Offset curve using this frame as a plane and B-rep edges and joining the naked curves. Now it's offsetting to the outside, so we'll bring in a negative and offset to the inside. Okay. And now between these two, I can create a surface, so boundary surfaces between this and this. But notice they overlap unless you bring in this graphed tree component, which will make it so they're organized correctly. And now we can extrude relative to this frame. So extrude, direction, well, it's going to be in perpendicular to the frame, or it could be off of the normal. The amplitude is going to be by how much, so we'll do 0.125. Now here's what happened, is that the extrusion of this is past the frame. So now we need to subtract this. The height of this, subtract by the frame, which is here. And it has to be a vector, so you can add the vector. We'll hide the input on this, and we'll subtract the vector. Now this can be the number to extrude this. Notice that it shortened it because it extended it back down to where it was supposed to be. And same thing with this one. All right, so we'll do the exact same thing, but this time we'll also, let's see, we'll bring this up. Now we're going to copy this and do the same thing to both the top and the bottom, but this one is going to be negative. So let's do it. Let's hide this and let's put together the door between these two and the door this one. That's the frame. And that's the door. Okay, so now we need to put together both this one and these two. So I'll go to union or solid union. We'll go this one, and this one. And then merge. Coplane our faces so we can see things clearly here. So now notice that this is our door. Now we need to go back and bring back our frame. And let's see here. Now we can rotate this. So we're moving this over because now this is what's going to be rotated. Right now it's rotated by 0, so it's obviously staying in the same location. And now we'll hide the wires on this so we can rotate it and show it. Okay. So now let's take it let's organize it. So I'll go here to an empty geometry component, bring that in, hide the wire display to hidden, then the door to this one. So we have these two. And now technically, since we taken the outputs and simplified them into these two components, we can disable the preview on most of this stuff. And so we can see it a little bit better. Then I'll bring in a custom preview with a material, which is going to be a color picker. And when we plug those in, I do like to hide the wire on this one. This one will be a little bit darker, and then the door will be down here, which we can change to maybe a darker green or something like this for now. So let's look at all the components. Door length, door height. This is going to be the depth of the door, so 0.1. Then door frame, trim size. And I'm grouping that one. And then this one is going to be 0.1. Door trim depth. Door swing float. This one is the door trim depth, so 0.05, and then the door frame offset. Now, a lot of these names are just subjective, right? Like it's just what I think that they should be called. Now, there could be more technical or more precise terms for whatever script you're making, and that's what's cool about creating a script, is that you're kind of in charge of what direction you want to take things. So this angle of rotation, we can also change this. Oh, we can even go -90. Now here's the thing, if we go like this, this is going to be the door swing location. So notice that depending on where you want it, you might have a different approach. Now, this one, if it goes in like that, that's incorrect. So then here, you can almost say minus 90. In the sense that you can also swing it the other way, this way. And then if that's not it, then that's it. So what's useful about this? Let me show you. If I took this line segment and I created it here like this, not even aligned, let's check and see if this works. Because this is kind of the point of the parametric script, right? If I set this curve and I plug it in, does it still work? And it does. So we can change the size of this to be whatever we want. You can have them within a floor plan and then just go back here and bake it. Now, this is more of an exercise one. I have two other versions that I'm sharing with you. I'm going to have the video script, which is this one. Then we're going to have another script, which is going to be the other one that I created in the initial work session. And then the last one is going to be the cluster, which is the simplified version of all of these. So if you want to download it, go to my website, capettidavid.com. There you can download this and other resources that can help you. Hopefully you learned something from this. You're excited to, move forward with your parametric skills. And I hope to see you on the next one.